Okay, so let's continue here with the module 3. Now here, let's look at what we call layer 3 logical addressing. Layer 3 logical addressing. So the IP packet, it contains two IP address, the IP package, or in other words, a package. So a package, it contains two address, that is the source address and then the destination address. The source address, it's the address of the sending device. For example, here this is the source and then this is the destination, the final destination, original source. So the destination, it's just the IP address of the receiving device. So this address may be on the same link or remote. That's when there is a source and then the destination, they can either be in the same group or the source can be in its group and then the destination also in its group. But those IP addresses, they remain, they will never, they will not change at all. They will not change at all. But when it comes to what we call the MAC addresses, for example, the MAC address, if you have source MAC, then source MAC, the destination MAC, in the same group or on the same network, still the source and destination MAC address, they are not going to change. But in case, let's say the destination MAC address is in another group, then automatically the MAC, both the source and then the destination MAC addresses, they are going to be replaced. That is what I talked about in the previous session about layer 2 address and then layer 3 addresses. The layer 3 addresses, most of the time they do not change, but layer 3 layer 2 addresses, for them, if source and destination are on different network, they do change, because there we expect what we call the encapsulation. So once once our packet is de-encapsulated, then at the time of encapsulation, the source and destination MAC addresses, they are replaced. Okay, so a layer 3 IP address, that is what our actual, anyway, I think we can actually look at this, because the statement here says that these addresses may be on the same or on remote network. So on this, an IP address, it contains two parts. It contains two parts. If it's 192.168.10.20, there must be a network, and how are you going to tell we need a subnet mask? A subnet mask, for example, 255.255, then maybe .0. Now here where we have a 0, now this one here, it will be like this. This is the network portion, and then this other one, it's host portion. So do not rush to conclude if you don't have the subnet mask. It's the subnet mask that determines those two portions. So network portion, or the prefix in IPv6, is the leftmost part, which is this. The leftmost part of an address indicates network group, and each LAN or WAN will have the same network portion, each LAN or WAN. So this is a LAN now, it has to have the same portion like this. Then all this portion here, they are going to keep on changing, which is this. So the host portion, or the interface ID for IPv6, the remaining part of the address identifies specific the IDs of the PC. And this portion is unique for each device. They are not saying unique for the network, unique for each device. But the network, it is the same, it remains the same on all the devices. On all the devices. So when devices are on the same network, the source and destination will have the same number of network portions. So you can actually judge by looking at this and then this. But this one here, it is not enough Still, you have to look at the subnet mask. You have to look at the subnet mask. The subnet mask is the overall factor that will break a tie to tell whether this in the different, this IP address and the source and destination, whether they are on a different network. But when you look at this, they're on the same network here. On this, it's the same group. It's the same group. So on this, the IP address remains the same. At the same time, the MAC address remains the same in the frame, in the frame or in the communication. But once the communication crosses one network to another network, the MAC addresses they are going to be replaced. So role of data link layer address, same IP data link layer addresses, same IP network. So as you can see, I've already explained that since they are in the same they are in the same group, the MAC address in the frame it remains the same. So it will just, of course, this is the device that is going to interlink this and then this. So the MAC address in the frame remains the same. Devices on a remote network, what happens when an actual destination is not on the same LAN and is remote? What happens when PC1 tries to reach the web server? PC1 to reach the web server. So the MAC address, the IP addresses are going to remain the same, as you can see this one here and this, they will remain the same. But now that they are going through, the communication is going to go through the packet, it goes through the router. So every time a router receives, it's going to do the de-encapsulation. At the point of encapsulating the packet again, then the source MAC address and then the destination MAC address, because for this, the source it will be this, and then the destination it's going to be this. But the source IP address it's this, destination IP address is this, and it's clearly stated here when you look at it. The source IP address is this, the destination IP address is this, but in this step, in this scenario, that the destination MAC address is this for this point, and then the source MAC address for this point it is A, which is this. So this router is going to receive it and then does the checking. Where is it coming from? From this destination, it's here. What about the IP addresses? The layer 3, it's from this, and the real destination, the final destination is this. Then this router is going to encapsulate the packet by replacing the source MAC address and the destination to the other. So this time the source it will be for this interface here, and then the destination it's going to be the other point, the next point, the next point on the pass, Okay, so we can go ahead. The role of network layer, the network layer access. When the source and destination have different network portion, this means that they are on different. Now, when you look at this, we have 192.168, but we have this one here, meaning that this is a group on its own different from this. So they are totally different. So in between we need a router, and once you have a router there, then it means that the source MAC address and destination MAC address from the sending device, when that packet or the frame reaches the router, it's going to be replaced. For example, let's assume we have a router, and then this is our PC1. We have MAC 1, we have MAC 2, we have another PC E10. So we have MAC, we have MAC 11, then we have MAC 10 here. So at this point here, when this PC sends, the source MAC address would be MA, and then destination M2, and then of course the IP address, but the IP address will be here 1, and then this one here 10. That is how they are going to be. So when the router receives, it will be, what's the source? It's the source MAC address, it's M1, destination it's M2, okay. And then that in that process it is de-encapsulate, it's doing the de-encapsulation. And after learning the destination, the final destination that is 10, then this router is going to encapsulate again by replacing this. This time it will be M11, which is this as the source, and then the destination M10. And then of course the source IP address will be a 1, and then the destination, final destination IP address, it's going to be a 10. I hope now you're getting the concept. The role of data link layer address on different network. This is what I was explaining. That at the time when this computer wants to communicate with the web server, that the source MAC address is this, the destination MAC address, it's going to be this. When this server receives, the source MAC address will be this point, and the destination MAC address, it's going to be this in the frame, but the IP address remains the same. It's not going to change in the package. So you can actually read through in this that when the final destination is remote layer, a layer 3 will provide layer 2 with the local default gateway IP address, also known as the router address. From here, now that if it's the destination, then automatically the destination here, it's going to be this with the MAC address, source MAC address, and then destination here. Then this router does the encapsulation. In the process of doing the encapsulation, it will learn the final destination. Once it learns the final destination, then the frame is going to be re-encapsulated or encapsulated again with this time new source MAC address and then the destination MAC address. So all this within so far what I've explained, you have to read through, and then where you get the challenge, you will have to come to class and then pose you pose the question so that you can get the clarification. Okay, so data link, here we have our data link layer access. Since data link addressing is local addressing, it's local addressing, it will have source and destination for each segment or hop of the journey to the destination. Hop of the journey to the destination. So hop of the journey to the destination, there are these ones here, the points, the next points, the next point. The next point. So the MAC address, the MAC addressing for the first segment is, so we have the source is PC1 network interface card, which is this, sending the frame. But the destination, it's not going to be the final destination, since the MAC address, there are local addressing. They are local addressing. So here, the destination MAC address, it will be the first router default gateway interface receives the frame. So it's this point to this point. So from the PC here, the source MAC address, which will be this, the destination MAC address will be this. But the IP address for them, it is going to be this as the source, and then the destination this. They won't change. And then step number 2, still the MAC addressing for the second hop. The source, the source now, it will be the first router exit interface, which is this. Now this time, our frame here, the source, it is the source MAC address, it's this point, and then the destination MAC address, it's this point. And then this router, it will receive, and then still does what we call the encapsulation. So the destination, as you can see, it's the second router. There's the second router receiving frame, so it receives here. And then this one, the last one, the MAC addressing for the last segment is the source, the second router exit interface, exit interface, which is this. It will be the source, as you can see now here, and then the destination is going to be that. So notice that the packet is not modified. The packet, this one here, the packet is not modified, but the frame is changed. So the information in the frame is the one that is changed, but the information in the packet, it doesn't change. Therefore, L3 IP addressing does not change from segment to segment, like layer 2 MAC addressing. So the layer 2 MAC addressing, they keep on changing segment to segment, segment to segment. So layer 3 addressing remains the same since it is the global, and the ultimate destination is still the web server. So it can't change. There is a lab here. Download and install Wireshark. You'll be guided. That is if you use your accounting and you go through the content. So still in this lab, you will do the following. Part 1, capture and analyze local ICMP data in Wireshark. Capture and analyze the remote ICMP data in Wireshark. So that is the end of the our module. Thank you.